Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over valence electrons and core electrons and how to identify them in your electron configuration. And so the first thing you want to do is be able to write the electron configuration. So here in problem number 1 we're asked to write the electron configuration for germanium. And so we need to look that up in our periodic table. And we are told that it has 32 electrons. And so we need to fill in the electrons according to the order of the sublevels and the energy of those sublevels. So at this point, you should be able to write out the electron configuration. We have 32 electrons. So the electron configuration for germanium is going to be, we start with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we have 3d10, and that should give us 30 electrons. So we have 2 and 2 is 4 plus 6 is 10. Plus 2 and 6 and 4 is another 10, that's 20, and then we have 30 there. But we have a total of 32 electrons. So after the 3D comes the 4P, and we have 2 electrons in there. So when we're trying to figure out the valence electrons and the core electrons, we have to remind ourselves what valence electrons are. So the valence electrons are those electrons in what's called the valence shell. Well, okay, what's the valence shell? The valence shell is the outermost shell, the outermost energy level, right? So if we go back to our Bohr model, so here's our nucleus, here's shell number 1, n equals 1, right? Energy level number 1, and this would be energy level number 2. And then so on. This would be energy level number 3, right? So the outermost shell is going to be what we call the valence shell. And the electrons in that outermost shell, in the valence shell, are called valence electrons. So the number of electrons in here is going to be the number of valence electrons in your outermost shell. So the valence electrons are going to be identified by the n number that is the largest, right? And so we remember that the number in front of your letter, that's your n value. That's the principal quantum energy level, right? So n equals 1 here. So for these two, n is equal to 2, and so on. So when you want to identify the valence electrons in your electron configuration, you're looking for the largest number. And you're looking for the subshells that have that largest number. So you'll notice here we have 3, we have 4, and 3, and then 4. So the largest energy level that we reach is 4. So any electrons that are in those numbers or in those sublevels that have that energy level, those are going to be your valence electrons. So here we have 2 electrons in the 4s and we have 2 in the 4d. We do not count the d electrons because it has a 3 and that is lower. So the number of valence electrons here, I'll just say V for valence electrons, is going to be 4. The rest of the electrons, the ones that are at the lower energy levels, those are going to be inside, so we call that core. So these would be the core electrons, anything that's inside the highest energy level. That's going to be considered core. So the valence electrons are these. Everyone else is considered core. Okay. So what else is there? So let's go on to the next problem. So we've identified the core electrons and we've identified the valence electrons. Okay. So what about phosphorus? So how many electrons does phosphorus have? If we look at phosphorus, it has 15. So phosphorus has 15 electrons. So we're going to write the electron configuration for phosphorus. So again, we'll follow the order. So we'll start with 1s, 2 electrons in the 1s, 2 electrons in the 2s, and then we have 2p. So we have 6 electrons there. That's 10. And then we have 5 more electrons. So phosphorus again is 15. So that means we have 5 more electrons. After the 2p is the 3s. So there's 2 there. We have 3 more. And then we have the 3p. So those 3 are going to go into the 3p. So again, here's our electron configuration for phosphorus. We want to identify the core and the valence electrons. Again, the valence electrons are going to be in the highest energy level. So we have 1, 2, and 3. 3 is the highest. So these 2 sublevels are going to be where your valence electrons are. So we have 2 electrons here, 3 electrons there. So the number of valence electrons is going to be 5. So those are 5 electrons. So these are the valence electrons. These are the core electrons. So the other thing you want to keep in mind is with regard to valence electrons, you should be able to identify the number of valence electrons from the periodic table. And so the number of valence electrons is always going to be equal to the group number if we're talking about the main group elements. This only refers to or works with main group elements. So those are going to be your non-transition elements. So the 2 in groups 1 and 2 on the left side of the table, and then you got those 6 on the right side of the table. So those 8 groups are your main group elements. And so they usually have an A in front of the group number. So 1A, 2A, 3A, 4A, and so on. So those are your main group elements. And so the group number for your main group elements is going to be equal to the number of valence electrons. And so the 1A, if you're in group 1A, then you have 1 valence electron in your atom. So one electron in your outermost shell. If you're in group 2A, then all elements in 2A are going to have 2 valence electrons, which means they have 2 electrons in their outermost shell. And then you have 3A, that's going to be 3 valence electrons, 3 electrons in your outermost shell. And then 4A is 4 and 5 and so on until you get to the noble gases. And the noble gases all have 8 electrons in their outermost shell with the exception of helium. Helium only needs 2. So that is how you can determine the number of valence electrons in your element. So you'll notice that phosphorus is in group 5 and it has 5 valence electrons. Okay, germanium has 4 valence electrons and you'll see that it is in group 4. Okay. So I hope this is helpful. I hope that you understand the distinction between the valence electrons and the core electrons. The core electrons are the electrons that are going to shield the nucleus from the outer electrons, the valence electrons. And so remember what we said about penetration and shielding, right? So that's going to play a part in shielding. So the core electrons are the electrons on the inside, and the valence electrons are the electrons on the outside. I hope this was helpful. If you like this video, share this video with your friends. Hit the notification bell so that way you're notified for any videos I put out. Hit the subscribe button so you subscribe to the channel, and make a comment in the comment section. Let me know what you think and if you have any questions that you might want me to answer. Thanks for joining me, and I'll see you next time.